What is up, everybody? This is the last inverse trig derivative that we're going to be doing. So why did I break it up into three videos? So let's take a look at three different trigonometric functions. So let's look at the derivative, the derivative of sine. Let's look at the derivative of secant. Sine. And then let's look at the derivative of tangent. So, the derivatives of these are going to be different. Sine is straightforward. You get cosine, right? Always to the x, right? Or to theta, or any variable. The derivative of secant is secant x tan x. And then the derivative of tan x is secant squared. So what are the differences? So you put in one function, you get one function. You put in one function, you get two. And then you put in one, and you get a square. So these are all different, but these are the only ones that we're going to be looking at. So I've already done these two. Now we're just left to do this. So let's get right into that. Okay. So the derivative of tan x equals 1 over 1 plus x squared. As always, we need to prove it. How can we prove that? Well, this is how. Let's start off. Sorry, it's 10 to the negative 1, by the way. All right, so let's go. So let's start off with just arctan. So 10 to the negative 1, x equal to y. And then let's take its inverse, which is normal tangent. So 10 to the 10 negative 1 to the x equals 10 to the y, because whatever we do to one side, we have to do to the other. And now, since these two over here are inverse, they cancel out. So now we're just left with x equals tan y. Now, for a clear, just for a better looking image, let's just write this as tan y equals x. So, once again, always drawing a triangle. We like to draw them. They help us visualize things. Beautiful. So we see over here, we have a right angle. Then we have our angle y. And then we have our side x. So what is tan? Tan is opposite over adjacent, right? Yes, that is right. So we're going to be taking that out. So it's our opposite. Our opposite is across the angle. So this is our opposite. And our adjacent is over here. And it's 1 because x is over 1. Now we have enough information to solve for the derivative. Let's start off. d by dx tan y equals d by dx of x. As we know, here there is no issue because it's with respect to x. So this is equivalent to 1. But this one here, we're deriving with respect to x, but we have tan of y. So it's a little bit trickier. So all we have to do is use implicit differentiation, which just means take the derivative of tan, which is secant squared x, and multiply it by dy by dx. Now we divide by both sides secant squared x. And then we're left with dy by dx is equal to 1 over secant squared x. Now, here's the best part. Let's solve for this side of the triangle right here. Let's solve for this side. How can we do that? Well, we can solve for that using Pythagorean theorem. As we all know, c is equal to a squared plus b squared. So let's write it over here. So this is equal to the square root of 1 squared plus x squared. We know that 1 squared is equal to 1, so we don't even have to write the squared. But Now we know our angle. So let's go. Back here. What is our secant? Well, secant is opposite of cosine. And cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Which means we're left with 1 over. What's our secant? It's hypotenuse over adjacent. So our hypotenuse is this, right here. So 1 plus x squared. What's our adjacent? It's 1 over 1 squared, because we have secant squared, as it says right over. Let me show you guys right there. It's squared. So we all know that the square root and the square are basically, they undo each other, right? So that's like saying just take away the square root. So our derivative is 1. Oh, hang on, my dog's barking. What's wrong? 1 over 1 plus x squared. If you don't understand how we did this, let's look at it this way. What does the square mean? It means a times a is equal to a squared, right? So 1 plus x squared under a square root is like saying the square root of 1 plus x squared times square root of 1 plus x squared. And one of the rules that we use with square roots is the square root of a times the square root of a is just equal to a. So, thus meaning that by doing this squared, we basically just take out the square root and we're left with this. If you notice carefully, hang on, my dog is going through my school bag. If we look at this very carefully, we see that this over here, all this matches up perfectly with this. Lucy, stop. Lucy, stop. Matches up very well with this. Would you look at that? And that's how you prove it.